In this video, we're going to talk about finding increasing and decreasing intervals. And how we're going to approach that is very similar to how we would do it by hand. When we do an increasing and decreasing interval by hand, we need our first derivative. So what we're going to do is use the calculator to help us do that. So in our y1 line, we're going to go ahead and type in our original function. So I'm going to pause the video while I do that. Okay, so now I have our original function typed in, and instead of trying to take the derivative and simplify it and make it so I can type in my derivative into the calculator, I'm just going to let the calculator do it for me. So now here comes some button pushing. To have a calculator do the derivative, you're going to need to press the math button, which is located right here below the alpha key, and it's quicker to arrow up to get to the bottom of the list, and you'll notice it's down here at option number 8 where it says n deriv. So if we hit enter, you'll notice the new operating system looks like this. So with the new operating system, I'm going to show you how we type it in, and then I'm going to go ahead and show you how we do it with the old operating system. So with the new operating system, it's saying what do you want to take the variable, or what do you want to take the derivative with respect to? We want with respect to x. I'm going to go ahead and fill in with the x variable. Now, what do you want to take the derivative of? Now, you could either go ahead and type in your original your original equation into here, or you could use the y1 variable, and that's located under vars. So we're going to go ahead and press vars. Up here, you notice we have the option of yvars, so we'll arrow over to that, and it's a function, so we hit enter, and it's located in the y1 line. So now in our derivative, you'll notice we're saying we're taking the derivative with respect to x of your your function that you typed in y1, and I arrow over here, and now it's saying after you do the derivative, what value for x would you like me to plug in? What value for x would you like me to substitute in? The number 5, the number 7, where do you want to interpret? Well, we want the whole function, so we're just going to do x again. So we're saying don't substitute in a value, leave it as x. Now, if I were to hit graph, it's going to graph my original function and then my derivative function on top of each other. That might look a little confusing. So what I'm going to do is go ahead and arrow over to the equal sign here. So I put my cursor over the equal sign on my y1 equation. I hit enter. And now what that tells my calculator is I don't care about the graph. Don't graph it. So now when I hit graph, I'm going to put us to a standard window. When I do graph, I'm going to be getting the graph of just my derivative. Now notice how slow the calculator is going. When you do this, when you do derivatives in your calculator and you're going to start using this method, you want to not hit graph until you're sure you're ready, because the calculator will take a very long time. So let's stop and think about what we want. If we were doing this by hand, how would you find increasing and decreasing intervals? Well, you'd say, all right, I'm going to take the derivative, I'm going to set it equal to 0, and then I'm going to make a number line. And all of those equal zeros, all those critical values, I'm going to put them here and here, right? And then once I have those values, I'm going to test the region to the left, the region in between A and B, the region to the right of it. And if it's positive numbers, then I know my graph is increasing. If it's a negative number, then I know my graph is decreasing. And we're going to break it up into those intervals. But also don't forget, we also need to include in here, because we can have a change at a vertical asymptote, which we already found is at negative 0.26. So what we're going to do is go ahead and include that on our number line as well. Now, I don't know if it goes there. We'll fill that in a minute. So we made a plan. Our plan, the thing we need to get out of the calculator, is taking that first derivative, setting it equal to 0, and finding what x values satisfy that condition. So how did we do that before? Well, we've already got the graph going, but what helps us really see those intercepts, what really helps us see where it's equal to 0, is by taking our window and changing our y range to be a very small region. So maybe we'll go negative 0.1 and 0.01. So now my y values are going from negative 0.01 to positive 0.01. So if I have an x-intercept in between the values of x equaling negative 10 and positive 10, I should see it. So I hit graph, and you can see here it's ticking along, and we can actually see the derivative graph a little bit better. But do you see now, because we made our y range so small, it is clear as day. where we have our critical points. It's clear as day where our first derivative is equal to 0. So we're going to go ahead and find these intercepts, these x-intercepts, find these zeros the same way we did for finding x-intercepts. And for finding the setting the denominator equal to 0 and all that. We're going to go to the calculate. So second, calculate. We want the 0. And now I'm going to move my cursor. Notice my cursor starting at the x value 0. It looks like I need to move a little bit over to the left. There we go. And notice my x values aren't so narrow now, so I can actually see everything. So here we go. We are on the left side of that x-intercept. So I hit enter. Now I'm going to arrow over. Notice, watch the y values. When I go from negative values to positive values, I know I've sandwiched my x-intercept in between. So I'm going to go ahead and hit enter, and hit enter one more time. And there we go. So I know my first critical point, my first value to put on my derivative number line. So here we go. Let's reset this here. So for my derivative number line, the most negative number down here is negative 1.733 and change. I had a vertical asymptote at negative 0.26, so that's going to go somewhere over here, negative 0.26. And then you can see from the graph our next critical point, our next first derivative equaling 0 is in the positives, so I know it's going to go over here. And we'll do the process again. We're going to second calculate. I want a 0, and I want to move my cursor close to where I want to be. And the trick here is I want it to be on the left-hand side of my x-intercept. So do you see we're still on the left-hand side of it? My y values are positive, so I'm going to go ahead and hit enter. Now I want my right bound, so I have to get my blinky cursor to the right-hand side. So there we go. And notice, watch for the y values to go negative. I hit enter. I hit enter one more time. And we get a critical value of 1.74, well, let's just call it 5 with rounding. Yeah, 50. There we go. Okay, so now I've got values. How am I going to get my increasing and decreasing intervals? How am I going to figure out what my slopes are? Well, looking at the graph, we can clearly see the values to the left of our first intercept, to the values to the left of negative 1.7 and change, were negative values. So you can see right here, these would be negative. Then the values between 1.733 and negative 2.6, well, you can see that looks like that's what's influencing in here, and it looks like our values are going positive. And we'll verify this with the table as well. And then you can see my values coming from this negative 0.2 and change, and then all the way over here all look to be positive. And then last but not least, my values after 1.7 and change are all down below the x-axis, so those would be negative. So we can again verify this by using the table of our calculator. Since we still have it in the mode where it's asking for values, I can just type in any number I want. So picking one number that's to the left of negative 1.7, well, that'd be negative 2. It's an option. Notice the value we get out, our derivative graph is telling us it's a negative value. There we go. So now I need to pick a value somewhere between negative 1.73 and negative 0.26. So let me add a 0 in there. It's bothering me that I don't have a 0. Negative 0. There we go. So I'm going to type in the value of negative 1. Notice the value we get out of that is positive. Similarly, we just need to pick a number somewhere between negative 0.26 and 1.7. So we could always try 0. Notice that's a positive 1. So on our number line here, we have a positive. Let me label that this is derivative. Okay. And then similarly, outside of 1.7, that would be a good value. That would be 2. And notice we're getting a negative number out. Negative number. So that's how we can use the calculator to build our increasing and decreasing intervals. So now we just need to write our answer. So let's start with increasing, since that's the first line. Do you see so what we're looking for is anywhere we have positive slopes. So since we have positive slopes there, I know I'm increasing from negative 1.733 up to the value of negative 0.26. And then I am also increasing from negative 0.26 up until 1.750. Then similarly, same logic, decreasing. We have no bound to the left. There was no critical values, so therefore we know there was no maxes or mins or anything that would make us go from increasing to decreasing outside of here. So therefore I just know from negative infinity, from negative infinity up until negative 1.733, and then we are decreasing, and then we're also decreasing from 1.750 up till positive infinity. So that is how we get increasing and decreasing intervals using the graphing calculator.